Hi. Um, so in one of our previous videos, we looked at how we can determine the general solution for this second order uh, homogeneous differential equation. And what we did is that we used a trial solution. So what I mean by a trial solution is where like you first of all like solve for the auxiliary equation, where you say m squared here plus 1 is equals to 0. So this is to help you to determine the type of roots that you're going to have. It's either you have complex roots, or maybe um, you have real distinct roots, or you have real identical roots. So those are the ones that are going to guide you to know what type of like they, they are going to help you to like get the expression that you're going to use for the solution of that particular differential equation that you're dealing with. And we ended up with y equals to that was a cos x plus b sine x. So you can actually check out the video where we came up with this solution in the description below. Okay, so what we now try to do is to see if by method of power series we can still come up with this one here, and our a and our b is just a constant there. Okay, so now let's look at how we can work this one out. So when it comes to the power series method for solving differential equations, the basic idea to finding a power series or a series solution to a differential equation is to make an assumption that we can write the solution as a power series. Okay, it's more like we make an assumption that we can write the solution of this one as a power series in the form y is equals to you have infinite sum from n is equals to 0 to infinity. Then here you're going to have your a sub n multiplied by your x minus x initial to the power n. Okay, so you observe that in most cases this is just written as y is equals to you have your infinite sum there, that would be from n is equals to 0 to infinity. Then you have your a sub n x to the power n. This is what is used in most cases simply because your x initial is oftentimes 0. In some questions, we tell you to say maybe determine a series solution for the following differential equation about x initial equals to 0. So meaning when you plug in a 0 there, you're just going to end up with that one. Okay, so one of the steps in solving for series solution of differential equations is to combine everything into a single series. So we are going to have a series for this one, and you're also going to have a series for this one here. So one of the steps is to combine everything that you have as a single series. Okay, and one of the ways in which you do that is, first of all, um, you have to shift the index of a power series. So we looked at how we shift the index of a power series in the previous videos. You can check out the link in the description below. Okay, so what it is here is that it's just basic substitution, as I would call it. So where there is y here, we're going to substitute with this series. Where there is y prime prime, we have to find what our y prime prime is, or our second derivative. Okay, so how we find the second derivative is very simple. So just have to differentiate what we have here, and it's just simple differential calculus. So you're going to have your y prime being equals to um, you still have your infinity there. Then here I'm going to start from n is equals to 1. So my n is going to drop. Okay, you are differentiating with respect to x, so my n is going to drop. I have my a sub n, then that will be x n minus 1. So you observe that you might wonder to say, why have I changed from 0 to 1? If I plug in a 0 here, everything's just going to be 0, and I'm trying to avoid that, hence I need to start from 1. And the same happens for the second derivative. You are still going as high as infinity, then n should be equals to 2. Then here you're going to have your n minus 1, the power has dropped, then that would be your n, then a sub n, that would be your x to the n minus 2 there, like that. So we need to get what you have here to substitute there, and you get this one and substitute right here. Okay, then we'll try to combine them but before we do that, we're going to shift the index. Okay, so let's write this one. We have this, that would be n is equals to 2. Then we have our n minus 1, that is our n, a sub n, then x n minus 2. Okay, that's plus our y. What is our y? Our y is what we have here. So this method appears to be a bit longer for such questions. Of course, there are some questions where you can't use, let's say, methods such as variation of parameters, or method of indeterminate coefficients. But some questions, they specify that you're supposed to use the power series method, so it's important that we know how to go about it. So remember, I said one of the important steps is to combine both these series as one. And before we do that, you observe to say we can't combine them just yet, because this series is starting from n is equals to 2, but this one is starting from n is equals to 0. So what we do is that we need to shift the index, in that they need to start from the same point. If they are both starting from 1, let them start from 1. And even the power of x need to be the same. And conventionally, it's just supposed to be x to the power n. Okay, so since this one is starting from n is equals to 0, and it already has x to the power n, I just need to shift the index for this one. So even if you have 4 sets of series, then you observe that maybe 2 of them are starting from n is equals to 0 and they have x to the power n. You can shift the other 2. Try to leave out the other 2, like the other ones that are okay. So in this case, I'll let this one be, then I'll have to work out this one. So shifting this one thing that I observe is that if I'm to make my x to be just x to the power n, where there is n, I need to substitute with n plus 2. So the substitution that I'm making is that I need to say my n is supposed to be equals to n plus 2. So it comes in to say, we have your x, where there is n, you plug in n plus 2 minus 2, this 2 that is there. So you observe that this is just going to become 0. Okay, then I'm going to come here and say, okay, so this is going to be, we're still going to infinity. So observe that if I plug in where there's n here, if I put n plus 2, this is just going to be n is equals to 0, because you have like n plus 2 is equals to 2, and that can cancel and that can cancel there. Okay, so where there's n here, if we plug in n plus 2, this is just going to be n plus 1. Okay, n plus 1. Where there's n here, put n plus 2, that's going to be n plus 2. Then you have your a sub n, so that would be your a sub n plus 2. Then that would be your x to the n plus, we have from n is equals to 0 then to infinity there. Then you still have your a sub n x to the power n is equals to 0. Okay, so one thing that you observe here is that we can combine this as a single series, because this one and that one are the same. So you can simply say they are starting at the same point, and the value of we have both here x to the power n and x to the power n. So I'm going to write it like this, from n is equals to 0. Then I'll say open bracket, I'm going to write this one here, which is my n plus 1. Then you have your n plus 2. Then this is a sub n plus 2, okay, plus a sub n. I close, then I'll have my x to the power n there is equals to 0. So this is just more like the coefficient, and this is what you're going to use to find what our a sub n's are. Okay, so we need to come up with a recurrence relation. So a recurrence relation is what you're going to get from what you have here. Okay, so let's see how we come up with that one. So I can place it there. So what it is that using what you have here to come up with a recurrence relation, you just have to ensure to say you you now solve for the a sub n that has the highest power. So you have a sub n and a sub n plus 2. Okay, so meaning we have to equate this to 0. What you have inside here has to be equated to 0 because that's the coefficient of a of x to the power n. So this is going to be n plus 1 multiplied by n plus 2 by a sub n plus 2 plus a sub n is equals to 0. So here make the a sub n that has the highest power the subject to the formula, and it's simply this one here. So this is going to be a sub n plus 2 will be equals to minus a sub n divided by this will be divided by n plus 2 multiplied by n plus 1. So this right here is our recurrence relation that we are going to be using to come up with the terms that we need in order for us to determine what type, the solution that we have for this differential equation. Okay, so what you do here is that you just need to start substituting, like let's say from n is equals to 0 up to maybe n is equals to, okay, you can go as far as you'd want to go. I'll try to go as far as maybe n is equals to 5. Okay, so if I come here and say what do I get? Okay, what do I get when n is equals to 0? So if you substitute here where there is n is equals to 0, this is just going to be a sub 2 is equals to minus, this will be a sub 0 divided by, so if you put 0 here and if you put 0 here, you're just going to get what? 2 times 1, which is still a 2. Okay, so let's try to see what we're going to get when n is equals to 1. Okay, so when you plug in a 1 there, this is going to be a sub 3 is equals to minus a sub 1 divided by, you put a 1 here, you put a 1 here, this is going to be a 3, and that's going to be a 2. So that's going to be 3 times 2. I'll write it like that. I don't want to convince myself that's a factorial for now. I'll just write it that way and leave it and see what I end up with at the end. So what if n is equals to 2? So we're going to say this will be a sub 4 is equals to minus a sub 2 divided by that will be divided by 4 multiplied by 3. What about n is equals to 3? This is going to be a sub 5 is equals to minus that would be a sub 3 divided by, that's going to be 5 multiplied by 4. If we say, let's say n is equals to 4, what we get is a sub 6 is equals to minus a sub 4 divided by that's going to be 6 multiplied by 5. Okay, so what about n is equals to 5? This is going to be a sub 7. Okay, that would be a sub 7 equals to minus a sub 5 divided by, that's going to be 7, because you put a 5 here, that's going to be a 7, and that's going to be multiplied by 6. Okay, maybe let me also add one. Let's say n is equals to 6. This is going to be equals to a sub 8 is equals to minus a sub 6 divided by 8 multiplied by 7. It's quite obvious, that's how it is. Okay, so what it is here is that I need to try to simplify this for myself. Okay, I need to try to simplify this for myself. So now what now do I have? So you observe that you have your a sub your a sub 0, which is your a initial. You have your a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6 there. So what to do here is that, let me try to see if I can simplify this. So like if you observe here, I have my a sub 2 to be equals to what I have here, but I have another a sub 2 there in terms of a sub 4. And again, I have a sub 3 here that is given in terms of a sub 1, but here I have a sub 3. So observe that we can try to simplify this one. Okay, so here where I have okay, let me see. Here where I have a sub 4, I I I believe I can write this. I can write this in terms of a sub 0, because a sub 2 is equals to what you have here. Okay, it's just more like you have your a sub 4. You say a sub 4 is equals to minus what is your a sub 2. We have that our a sub 2 is equals to that, which is minus a initial divided by 2, and that is divided by what we have here down, which is 4 multiplied by 3, like that. Okay, so we just observe to say our a sub 4 is just equals to a initial divided by 4 by 3 by this 2 here, like that. So that is what our a sub 4 is positive divided by 4 by 3 by 2, like that. Okay, so let's see if we can break more of these down. So if you observe here where you have a sub 5, a sub 5 is equals to a sub 3. What is your a sub 3? Is equals to a sub 1, and since I have negative and negative is going to be positive, so I can write this as a sub 1 divided by um, I have the 5 multiplied by 4 multiplied by the 3 here multiplied by the 2 that you have there, like that. Okay, let's look at how we can simplify the a sub 6. So a sub 6 is equals to a sub 4. What is your a sub 4? Your a sub 4 is equals to your a initial, but it's positive, so it's going to be minus a initial divided by, it's this one here, the denominator, multiplied by this one here, of which this is just 6 by 5 by 4 by 3 by 2, of which I can just simplify this as 6 factorial. And I think this I can just simplify the rest as well, because even this one I believe it's 5 factorial. This one is going to be 4 factorial. So we have 4 factorial here, and this is 5 factorial. So what about a sub 7? So a sub 7 we're going to substitute with a sub 5. Our a sub 5 is a sub 1 divided by 5 factorial. So if I say this is just going to be like a sub 7 equals to minus. Okay, what is my a sub 5? A sub 5 is a sub 1 divided by 5 factorial, but I have my 7 6 my 7 and 6, so it's just more like 7 factorial, like that. Okay, then what about your a sub 8? So you have your a sub 8 equals to, is your a sub 6. What's your a sub 6? Is a initial, and it's going to be positive because you have your negative times that negative there is going to be positive, so that's going to be a initial divided by, so you have your 6 factorial, but 6 factorial by 8 by 7, that's just 8 factorial, like that. Okay, so now how these end up simplifying is like this. Okay, so if you observe here, you're just going to be adding this one plus this one plus this one plus this one plus this one, and the list is just going to keep on going on and on and on and on. Okay, but of course we should not forget that it's more like what we are going to factor out as the coefficient, or like, yeah, as a coefficient, is just your a initial as well as your a sub 1. Okay, so now Here is how this one is going to unfold. This is just going to be you're going to say your y will be equals to. So if you add all of this together, you're going to have a situation whereby you have your a initial, okay, your a initial. Then I'm going to factor out because I observe that I can factor out this one, the a initial, then I have that other a initial, that other a initial there. So this one is just going to be something like, I'll say open bracket, this is going to be 1, okay, 1 minus x squared divide by 2 factorial, okay, divide by 2 factorial. If you remember, we earlier said because we have our a sub n plus 2 equals to a initial, that's minus, no, I mean a sub n divided by n plus 2 by n plus 1. So remember we said our for when we have a is a sub 2, that is when n is equals to 0, we are going to have minus a sub 0 there, or a initial divided by, that was what, 2, more like 2 factorial. This is why I've written it like that there. So I have the 2 here, so that's the 2 factorial, meaning it will correspond with the x squared. Yeah, I believe we are familiar with this when talking about the series and stuff, and it's negative for that matter. So this is going to be, you're going to have plus, that will be your x to the power 4, which is this one here, and it's positive, so that will be divided by 4 factorial. What follows is negative, that will be minus x to the power 6 divided by 6 factorial, okay, then plus you have your x to the power 8 divided by 8 factorial, and you can predict to say that the next is going to be minus wait a minute, this is to the power 8 divided by 8 factorial. So you can predict to say the next one is just going to be x to the power, because this increases by 2, you have 2, 4, 6, 8, so 10 divided by 10 factorial there, like that. Okay, so this is going to be minus, I'm going to put those dots there, then I'll say plus. What about my a sub 1? So my a sub 1 is going to be a sub 1 here, then you have your x minus, which other one do we have? We have this one here, we have our that's positive actually, it's x to the power 5, okay, x to the power 5 divided by 5 factorial, then we have minus it's this one here, x to the power 7, so x to the power 7 divided by 7 factorial, that would be plus this one is plus, so the other one is going to be plus, I think. Yeah, and the list keeps on going like that. Okay, so now let's try to simplify this one. Remember, when we used a trial solution, we ended up with y is equals to a cos theta, or let me say a cos x plus b sine x. So if you have done if you have tried to find the, let's say this the series, or the Maclaurin series for cos, this is what it is. Then for sine, it's this one here that is in the brackets. So you can just simplify this by saying this is your y will be equals to a initial a initial cos what, cos x, plus b in fact not b but a sub 1 as our coefficient. So that's going to be a sub 1 sine x, like that. Okay, and if you observe how this one is moving, you can write this as it's more like you're going to have your a sub n like that, then you have your infinite sum, you're starting from n is equals to 0, okay, you're starting from n is equals to 0, and then that would be to infinity. Then here the negative is changing, so I can put n here like that. Okay, is it making sense to be n there? Let me see. That would be your x, then x to the power 2n divide by 2n factorial, like that. Okay, so how this one is going to be is that on this one, if I'm going to treat this as my first term, this as my second term, this as my third term, and this as my fourth term. Because you might be wondering to say, why have I put a sub n here when when I have 2 here is negative? It's because I'm treating this one as my first, second, third, and fourth, like that, and it keeps on going. Then you can say plus your a sub n, and that would be you can try to work out the same here. You just observe how the sign is, the negative sign, how the sign is alternating. Look at how the denominator in terms of a factorial is also increasing, then you write it in terms of that. So one thing that you observe is that what you have here and what you have there, they are simply one and the same. Don't worry about having a initial and your a sub 1 there and having a and b there. Those are just coefficients. So that's simply how you find the power series solution for this second order homogeneous differential equation, which is y prime prime plus y is equals to 0. So that's all in this video. Thank you very much for watching.